Hello everyone, I am Amit Goyal. I welcome you all to the YouTube channel of IES Master. In the Master Concept series for GATE CS 2024, we are discussing the subject of theory of computation, and we have already taken 7 sessions on finite automata, and we have discussed in detail deterministic finite state automata. Then we discussed in detail non-deterministic finite state automata, and then we further discussed epsilon non-deterministic finite state automata. We have also discussed that the power of all these automata are equal, right? But still we make all these. Why? Because when we go from DFA to NFA, the succinctness improves. When we go from NFA to epsilon NFA, the succinctness even further improves, right? So that is why we make these automata to improve the succinctness, but the power of each of these automata is exactly equal. ठीक है, इन सब की पावर एकदम बराबर है, बस हम succinctness को improve करने के लिए इन automata को बनाते रहते हैं, right? So this session I have specifically kept as a practice session to discuss whatever we have already discussed, to check whether we have understood it well or not, or to also check that whether we are able to implement the concepts that we have understood on the questions, right? So let us try to see this practice session. Let us try to solve certain questions on in this practice session. All right. So this is the first question. So this is the question on epsilon NFA, and it has been asked in GATE 2017. All right. So yeah, so let me read out the question for you guys. Yes, so it says that delta denote the transition function and delta dash denote the extended transition function, right? So what is an extended transition function? What is the difference between the transition function and an extended transition function? Extended transition function is for the strings. Transition function is for the symbols in the alphabet, right? So for example, delta we write on one state, and then what if we receive a input symbol on that state? Now when I say delta dash, that is delta cap or delta dash, whatever you want to call it. So delta dash has been asked for Q2 comma ABA. So that means what happens on Q2 when we get the string ABA. So that is what are the states that are reachable when we have when we put ABA on Q2, right? So when we are doing this, the only difference that happens between delta and delta cap is that delta is applied on symbols in the alphabet and delta dash is applied on the strings, right? So let me read out the question fully first. So it says that the delta denote the transition function and delta dash denote the extended transition function of the epsilon NFA, whose transition table is given below. The transition table is given to you, right? So all right, so the transition table has been given to you. All right, so then delta cap of Q2 comma ABA is, so what is the delta cap of Q2 comma ABA? That is being asked, right? So it's a very straightforward question. It's an application of what we have already seen. So right, so we have already seen what is delta. How do we calculate the transition function of NFA if the transition function of epsilon NFA is given? How do we do that? We take the epsilon closure first, then we apply that symbol, right? And then we again take the epsilon closure. So when I say when we apply that symbol, that means I will apply the transition function of the epsilon NFA, and then I will again take the epsilon closure. So the same thing needs to be done 3 times here, first on A, then on B, then on A, right? First on A, then on B, and then on A. So the same thing needs to be done 3 times, and then what we get is the answer to this question. All right, I hope the idea is clear, right? So now let's see. So the first step, so this is the transition table which is given to you. I have written it here to use it. So first of all, the first task is to find out the epsilon closure of Q0, Q1 and Q2. Epsilon closure of Q0, Q1, Q2 as well as Q3. Let's do that. All right. So now epsilon closure of Q naught, if I want to find what it is, Q naught will always come in that. Now from Q naught using epsilon I can get Q2 also. So therefore Q naught will be there, Q2 will be there. Using Q2, using epsilon, what I get? Q naught only, that's already there. So Q naught, Q2 will be the epsilon closure. Epsilon closure of Q1, this is Q2 as well as Q1 as well as Q naught also. Why? Because on Q2, if you get epsilon, you will get Q naught also. So it will have Q naught, Q1, Q2. So let me write them in the increasing order so that we do not make any mistake. So therefore it is Q naught, Q1 as well as Q2. All right. Now, what is the epsilon closure of Q2? What is the epsilon closure of Q2? So Q2 is already there, then Q naught will also be there because of this. So Q naught, Q2 will be there. Now because of Q naught, can something be added? No, because Q2, Q naught will also give you Q2 only, right? That's it. Now epsilon closure of Q3 will only have Q3 because on epsilon I am only getting phi, so that means we will be only at Q3. So the state itself always comes, in the epsilon closure, in its epsilon closure, because you are already there without taking any symbol, right? So what is epsilon closure, by the way? All the states which are reachable from a particular state just by using epsilon moves, right? So you are on yourself without taking any move. So that's why. So the state itself always comes in its epsilon closure, right? So we have already found the epsilon closures. Now what is the next step? I have to calculate the extended transition function, which is just the application of what we have already done for the conversion from epsilon NFA to NFA. We have to apply that process 3 times. All right, let's see. So what is the string given to us is ABA, and we are already at the state Q2. Let's see Q2. Now, so first of all, my first step will be to apply the epsilon closure. So what is the epsilon closure of Q2? Can we look at that? That is Q naught and Q2. Q naught and Q2. Just a second, it is Q naught and Q2. Right, so this is the epsilon closure, that is Q naught and Q2, right? Now on Q naught, so first of all we'll consider A. Now what happens if I get an A? On Q naught if I get an A, on Q2 if I get an A, what happens? So on Q naught if I get an A, I will get Q1. On Q2 if I get an A, I will get phi, right? So Q naught, Q1, Q2, phi, and I have just taken the epsilon closure of Q2, which is nothing but Q naught, Q2, which is nothing but Q naught, Q2, correct? I hope till this point things are clear, right? So what needs to be done further? Now we have to take again the epsilon closure, that is the step number 3, right? First we take the epsilon closure, then we apply the symbol, and then we again take the epsilon closure. So that is how we apply that is how we calculate the transition function for NFA, right? So the same function, the same thing has to be done 3 times since it's a 3-length string, right? So let's see what happens on Q1. So Q1's epsilon closure needs to be calculated. What is the epsilon closure of Q1? So it is coming out to be Q naught, Q1, Q2. It is coming out to be Q naught, Q1, Q2. So this is the epsilon closure of Q1, Q naught, Q1, Q2. Now I will apply the symbol B, right? So let's apply the symbol B. Now what happens here? Now Q naught on B is going to again Q naught only. Q1 on B is going to Q3 only. And Q2 on B is going to phi. All right. So now I have Q naught, Q3 with me. All right. So I have from Q naught on B, I will take Q naught, and Q1 on B, I will take Q3. Let's apply it on Q naught, Q3. Right. Now I have to take the epsilon closure again. Let's take it. So I will apply epsilon closure again on Q0, Q3. The space is less, I'll come down now. I will write Q0, Q3 here. And I have to take the epsilon closure of both of them. So epsilon closure of Q0 will be again Q0, Q2. Epsilon closure of Q3 will be Q3 only. All right. So I'll get Q3 only. Right. Now I have to apply the last symbol. We have already applied B. Now the last symbol, that is A. If we apply A, let's see what we get, and whatever we get will be the answer to this question. All right. Let's see. So when we apply A again, A on all these states, what we will get? So Q0 on A is giving me Q1. Q2 on A is giving me phi, Q3 and A is also giving me phi. Now when I apply epsilon closure again, so I need to again apply epsilon closure to get the final result. So the epsilon closure is going to give me Q0, the epsilon closure of Q1 is Q0, Q1 as well as Q2. So this is Q2. So this is epsilon. Right, so the answer will be Q0, Q1 and Q2. All right, so let's go back and check that. We are getting the option C as the correct option. So the answer will be Q0, Q1, Q2. So it's just that whatever we have already learned, we have just applied the same thing 3 times. We first take the epsilon closure, then we apply the transition function of epsilon and Fa, then again we take the epsilon closure. We have to do it 3 times. Why? Because we have the length of the string here is 3. All right. So this is how we can solve such type of questions. All right. So let's go to the next question. So this is the question on epsilon and Fa, right? So let's see one more question. Right. So this is the example on DFA. So what is being said is, what is the number of states in the minimal DFA which accept set of all strings over sigma equals to 0, 1, which when interpreted as a binary number is divisible by 2, right? So what is being stated is, let me read it out again. What is the number of states in the minimal DFA which accept set of all strings over sigma equals to 0, 1, which when interpreted as a binary number is divisible by 2, right? So what is the meaning of this question? That you have been given binary strings and you have to tell by looking at that binary string that whether it is divisible by 2 or not. So which strings you have to accept which are divisible by 2. So in general, you can easily solve it by saying that this question can be converted into saying that if the string ends with a 0, then it is divisible by 2. If the string ends with a 1, then it is not divisible by 2. All right, so that's the only thing that we have here, right? And now the number is being divided by 2. That means the only possible remainders are 0 and 1. So the possible number of states will be 2 only. That is, one which is representing the remainder 0 and the other which is representing the remainder 1. So the 2 possible remainders are 0 and 1. All right. So that is one way of solving this question, and then you can easily plan. Right? Now, just a minor theory which I would like to give you before we go ahead and solve this question. This is one way. Another theory which should be clear to all of you, that is, so for example, if a binary number is given to you as 1010, we all know that this is equal to the 10 in the decimal representation, right? Now, how do we generally calculate the decimal representation? We go from the least significant bit to the most significant bit with increasing powers of 2. So this is 2 raised to power 0, this is 2 raised to power 1, then 2 raised to power 2, then 2 raised to power 3. So 2 raised to power 3 into 1 plus 2 raised to power 1 into 1, otherwise others are multiplied with 0. So this comes out to be 8 plus 2, which is 10. The problem with this approach is we have to go from the least significant bit to the most significant bit, but the number will not be given to you in this format. The number will be given to you from the most significant bit to the least significant bit. So how would you resolve this problem? So there is another way of converting the numbers from binary to decimal. You are already aware about it, but you might not have realized it. ठीक है, हमने ये already किया तो होगा, but we might not have realized this, right? So देखिए, हमारे पास है 1010. हम इसे क्या कर सकते हैं, इस 1 को, so जो भी हम LHS से शुरू होंगे, लेफ्ट हैंड साइड, दैट इज द मोस्ट सिग्निफिकेंट बिट से शुरू होंगे, और उसे हम मल्टीप्लाई करेंगे base of the number से, that is 2, base of the system, that is 2 in this case of binary. So 1 into 2 plus the next number, that is 0, what we get is 2. After that, whatever we have got, we will again multiply it with 2, that is 4. Then we add the next number. We have already considered 0, the next number is 1, so that is 2 into 2, 4 plus 1 is 5. Then 5 multiplied by the next number, multiplied by 2 plus the next number, we are going to get 10. So that way we are going to get 10. While converting an n-ary number into the decimal representation, what you will have to do, you will go from the most significant bit to the least significant bit by keeping on multiplying the previous calculation with the base of the number, then keep on adding the next digit, right? So that is how you can do it. All right, so let's see, this is how you can do it. So again, so how we solve this? Now we already know how to convert. Now initially you already know you have two states, one is representing the remainder 0, the other is representing the remainder as 1. So what to do here? Now initially if you have 0, so you already know that 0 is divisible by 2, so 0 will come here. Now after 0, 0, 0, 0, 0. Now, after 0, first of all, we also have 1. What about 1? 1 is not divisible by 2, so this is defined, this is defined. Right? Now, what about 0, 0? 0, 0 is again divisible, that's not an issue. What about 0, 1? 0, 1 is not divisible, this is fine. Right? Now, suppose we are at Q1, we have already got a 1, after that we get 1, 1. What is 1, 1? That is 1 into 2 plus 1, which is nothing but 3. 1 into 2 plus 1, which is nothing but 3. So 3 is divisible by 0, divisible by 2? No. So therefore we'll also keep this. Keep it here itself. Now what about Q1? Q1 on 0. We have already seen Q1 on 1. What about Q1 on 0? अगर Q1 पे 0 आता है तो हम क्या करेंगे? Q1 पे अगर 0 आया तो we have already got 1. So let us say we have already got a 1 and then after that we get 0. So this is 1 and then 0. I have put it like this. Why? Because 1 into 2 plus 0 is nothing but 2. 2 is divisible by 2. So therefore this here. So very simple, right? So and again, now what about the numbers which will come later? So this DFA which we have drawn for smaller string, it will also satisfy the strings, the larger strings also. Let us take one string as we took 1010. We know that 1010 is nothing but 10. It is divisible by 2. Let's see what happens. This is 1, then 0, then 1, then 0. Again it is divisible by 2. Right? So this satisfies. All right. So this is how you solve such questions. Right? Now, now let us see one more thing. Here, there is a simpler way of making such DFAs, right? And I generally call to my students, I generally tell my students that this approach is web DFA approach. What you have to do, you have to make the transition function. You can directly make the transition function for any such type of question directly. How? What you will do is whatever is the, so for example, if I am saying you have an n-ary number system and you are dividing by m, right? So let me do it for binary number system and divisibility by 2, and then I will extend it to any n-ary number system which are divisible by m maybe. So here you are dividing by 2, so you will have two states. The transition function will have two states, q0, q1, and what will be your sigma? Since it's binary, so you will have two symbols, that is 0 and 1. What you have to do is you have to fill the states in a cyclic order starting from the top, right? So left to right, ठीक है, top to bottom, left to right. So for example, here Q0, Q1, done. Then again the cycle will start Q0, Q1, top to bottom, left to right. So I call this approach as zigzag approach. Why? Because of the shape. Alright. So you can directly get your DFA, the transition function for the DFA. If the transition function is there, the tuple is defined. Why? Because your sigma is there, your Q is there, transition function is there. Now what is remaining? The initial state and final state. Here it is being said it's divisible by 2. That means the remainder is 0. That is Q0 will be your final state as well as initial state. Initial state will always be Q0. The final state will depend whatever is the remainder that you want. If you are saying divisible by 2, then it's fine. If you are saying not divisible by 2, then the remainder will be 1. So Q1 will become final state. Now if I want to extend it to n-ary number system, what will happen? This will go up to, let me take a different color. So 0 to 1 up to n minus 1. When I say divisible by m, so how many remainders will be there? 0 to m minus 1. The size will increase. And then you will fill the states Q0, Q1 up to Qm minus 1. Then again Q0, Q1 up to Qm minus 1 in a cyclic order, top to bottom, left to right. This is how you can fill this. As simple as that. Right? So again, this is very simple. You can extend this approach. Let us apply this approach on another example. Right? So this approach will work on any n-ary number system when divisibility by m is there. Right? Let's see whether we can apply it on an example or not. Let's see. So this question, so answer to the previous, this question will be what is the number of states? Answer is directly 2. You don't even need to make this, but this is the details. If a more tougher question comes on it, which is asking about the transitions, then you might need the transition function also. But if it is only asking what is the number of states, that is directly 2. You can solve it in seconds. You don't need to do all this juggling. Alright. So let's see. अगला क्वेश्चन क्या है? What is the number of states in the minimal DFA which accepts set of all strings over sigma equals to 0, 1, 2? So now the sigma has changed 0, 1, 2, and this is a ternary number system, which is very important. Ternary number system, and you are checking divisibility by 5. Now this is n-ary, so your n is becoming 3 here, and divisibility by 5 means your m is 5. So what are the possible remainders? 0, 1, 2, 3, 4. How many states? 5. Question is done. Within 5 seconds, 10 seconds, you can do this question. Answer is 5. But if I want to see the transition table, if I want to see the DFA, your zigzag approach will work here. So since your n is 3, so the number system is n-ary number system, the ternary number system, your sigma will be 0, 1 and 2. Your remainders will be Q0, Q1, Q2, Q3, Q4. How many remainders are there? 5 remainders are there. How will you fill it? Top to bottom, left to right in a cyclic manner. That is Q0, Q1, Q2, Q3, Q4, again Q0, Q1, Q2, Q3, Q4, again Q0, Q1, Q2, Q3 and Q4. That is how you can make it. Right? Yeah. Alright, I hope it is visible. Right? Alright. So this is how you can get this. Alright. So, and what will be my final state? Initial state will be Q0 only, final state is divisibility by 5. So this will be my final state. If somebody says the remainder is 1, then Q1 will become my final state. Remainder is 3, Q3 will become my final state, and so on and so forth. Right? Simple, straightforward, easy question. Alright? I hope the concept is clear. Alright. Okay. So let's see some more, one or two more interesting questions. Now let's see this important question, a good question on minimization. What is this question saying? What is the number of states in the minimal DFA of the given DFA? The DFA is given to you. So this is the question on minimization. The technique we have already discussed. We'll directly apply this technique here, right? So now we can see 5 states are there. The first step was to remove all the non-reachable states. Let us remove the non-reachable states. Q0 is reachable, Q1 is reachable, Q2 is reachable, Q3 is reachable, Q4 is reachable. There is no non-reachable state, unreachable state. There is nothing like that. So all the states will remain there. So right. Now next step is to find out the zero equivalent. What is zero equivalent? The states, the final states will come in one set and the known final states, the known accepting states will come in the other set, right? So what will happen? एक स्टेट में मैंने Q0 डाल दिया, Q4 मेरा फाइनल स्टेट है. So what I will do, my final state is Q4. So in one set I will have Q0, Q1, Q2 and Q3. In the other set I will have Q4. All right. Now let us try to calculate. This is zero equivalent. That is, on zero length input they have the similar behavior. Now what is one equivalent? That is those states which have the same set behavior. Again the word set behavior, not the state behavior, on accepting one length input, that is one symbol, right? So let's see what happens on Q0 if an A comes. Q0 on A goes to Q1. So let me change the color. Okay, let us keep it same. Q0 on A is going to Q1. And again, Q1 on A is also going to Q1, Q2 on A is also going to Q1, Q3 on A is also going to Q1, Q4 on A is also going to Q1. So everybody is going to Q1 only. So the set behavior is same. Now what about B? Now Q0 on B is going to Q2. Q0 on B is going to Q2. So this is Q2. Q0 on B is going to Q2, Q1 on B is going to Q3, that's also the same set behavior. Now, Q2 on B is going to Q2 itself, again the same set behavior, but Q3 on B is going to Q4, which is a different set behavior. So we will separate Q3 because it has a different set behavior. So what we will do is Q0, Q1, Q2, Q3 is separated, then Q4 separately. Alright. Now Q0, Q1, Q2, what is the behavior? Again, so this is your one equivalent. Now let's see if we can do any separation here. Now let's see again the set behavior. We already know Q0, Q1, Q2 all have the same set behavior, same state behavior. Forget about the set behavior, they have the same state behavior. That is, all of them go on Q1 only. So there cannot be any issue here. But what about on B? What about on B? Let's see their behavior on B. So Q0 on B is going to Q2, very good. Q1 on B, Q1 on B, so Q1 B पे कहाँ जा रहा है? Q3 पे. और Q2 B पे कहाँ जा रहा है? Q2 पे. तो again we can see Q1 has a different set behavior. वापस एक बार क्रॉस चेक कर लेते हैं. Q0 on B Q2 पे जा रहा है, बिल्कुल सही. Q1 on B is going to Q3, separate करना पड़ेगा. Q2 on B is going to Q2 only, same set behavior. So Q0 and Q2 will come in one set. Q0 and Q2 will come in one set. Q1 will be separated, Q3 will be separated, Q4 will be separated. Already separated means, right? That's already different sets, right? Now let's see. Q0 is done, Q2 is done. Now so Q0, Q2 we have to see can we again separate them or not. So let's see Q0, Q2. If I see Q0, Q2, Q0 on A, both are going to Q1. We already know Q0 and Q2 both go to Q1. Okay. So both are going to Q1. So they have the same set behavior. Now what about B? Now Q0 on B is going to Q2. Q2 on B is also going to Q2. So again the set behavior is exactly similar. So the final set that we get is Q0, Q2. So this was 0 equivalent, 1 equivalent, 2 equivalent, and the 3 equivalent is also same. We will stop here. 2 इक्विवेलेंट और 3 इक्विवेलेंट दोनों सेम है, इसलिए हम यहां पर रुक जाएंगे और हमें क्या मिल रहा है? Q0, Q2, Q1, Q3 and Q4 दो स्टेट्स आपस में मर्ज हो गए, तो आंसर टू दिस क्वेश्चन विल बी 4, राइट। अगर हम बात करें अगर Q की, तो Q कितना हो गया हमारा 4। सिग्मा की बात करें, सिग्मा विल रिमेन सेम। डेल्टा की बात करें, डेल्टा आपको ओरिजिनल ट्रांजिशन फंक्शन से मिल जाएगा। Q नॉट की बात करें, इनिशियल स्टेट विल बी दिस न्यू स्टेट कॉल्ड Q1, Q नॉट Q2, एनी द स्टेट विच कंटेन्स द ओरिजिनल इनिशियल स्टेट, दैट इज बेसिकली योर initial state. What is the final state? All those states which contain any of the final states of the original DFA. So Q4 was my final state, so Q4 will remain my final state. ठीक है, सो एक बार हम DFA भी देख लें, फाइनल DFA कैसा दिखेगा। दिस इज हाउ योर DFA विल लुक लाइक। ट्रांजिशंस कैसे कैलकुलेट करने हैं, ओरिजिनल DFA से आप ट्रांजिशंस ले सकते हैं। जैसे कि अगर हम बात करें Q नॉट Q2 का, Q नॉट Q2 कहां जाते हैं, A पे, दोनों के दोनों Q1 पे जाते हैं। दिस इज डन, राइट। नाउ व्हाट हैपेंस टू Q नॉट Q2 ऑन B? Q नॉट Q2 ऑन B, दे गो टू Q2 नाउ, which is now Q नॉट Q2, so this is done. All right, now what about Q1? So again, this we are doing just to explain it fully. The question has already been solved. The answer is 4, right? So now Q1 on A, Q1 on A goes to Q1 only. Q1 B पे कहां जाता है, Q3 पे जाता है। Now Q3 A पे कहां जाता है, Q1 पे जाता है, और B पे कहां जा रहा है, Q4 पे। and Q4 Q1 पे जाता है A पे, and B पे कहां जा रहा है, Q2 पे, which is now Q नॉट Q2. So this is how you can draw the complete DFA also. All right, so now let us see one last example, that is on NFAs, right? So this is the example. What is the number of states in the minimal finite automata which accept set of all strings over sigma equals to AB such that the string contains an AB? So this is very important. This is very important to see here. This keyword minimal finite automata. So when it is being said that you have to draw the minimal finite automata, you should always draw the NFA but not the DFA. Why? Because we already know NFAs are more succinct than DFAs. So when it is said minimal finite automata, तो आप क्या बनाएंगे, NFA बनाएंगे, आप DFA नहीं बनाएंगे। और NFA अगर आप बनाएंगे तो the string should contain an AB. So this is A, this is B. Before that anything can come, after that anything can come. पहले भी कुछ भी आ सकता है, बाद में भी कुछ भी आ सकता है, तो मेरा DFA NFA ऐसा बन जाएगा। तो आंसर क्या हो जाएगा इस क्वेश्चन का, व्हाट इज द नंबर ऑफ स्टेट्स? द नंबर ऑफ स्टेट्स विल बी 3। ऑलराइट, नंबर ऑफ स्टेट्स मेरे कितने हो जाएंगे, 3 हो जाएंगे। अगर आपको याद है कि मैंने एक NFA लास्ट एक सेशन NFA के सेशन में मैंने NFA बनाया था कंटेनिंग B वाला। कंटेनिंग B NFA में I told you that you can draw the NFA like this. This is like containing B, right? Right? और NFA में एक्सेप्टेंस कंडीशन क्या रहती है, एटलीस्ट वन ट्रेस शुड रीच द फाइनल स्टेट। ये मेरी एक्सेप्टेंस कंडीशन है, ठीक है। नाउ अब अगर मैंने आपको ये भी बोला कि आप क्या कर सकते हैं, आप एक ट्रांजिशन कंटेनिंग B मान लिया, या कंटेनिंग आई थिंक क्लास में हमने कंटेनिंग A डिस्कस किया है, अब कंटेनिंग B का बनाएंगे तो वैसा ही बनेगा, राइट। अब इसमें से मैं क्या कर सकता हूं, यहां से मान लीजिए मैं यहां पे ये वाला B हटा सकता हूं, राइट। दिस इज फाइन, दिस इज स्टिल एक्सेप्टेबल, राइट। व्हाई इट इज एक्सेप्टेबल, व्हाई, बिकॉज क्या होगा, मैं पहले ही B पे इस स्टेट पे आ गया, उसके बाद जो भी बीज आ रहे हैं वो ये वाला स्टेट मेरा एक्सेप्ट कर लेगा, ठीक है। मैं ऐसा भी कर सकता हूं कि नेक्स्ट लास्ट वाले बी को इरेज कर दूं और पहले वाले को वैसे ही रखूं। दिस इज ऑल्सो फाइन। मैं क्या करूंगा, लास्ट वाला बी जो मेरी स्ट्रिंग में आ रहा है उस पर यहां मूव करूंगा, उससे पहले जितने बीज हैं वो यहां पे ही रहूंगा इनिशियल स्टेट पे। बट मान लीजिए अगर मैं दोनों रिमूव कर देता हूं, अगर मैंने इस केस से दोनों रिमूव कर दिए, दिस इज नॉट एक्सेप्टेबल, दिस NFA इज नॉट करेक्ट। बिकॉज अगर मैं पहले अब इसमें एक ही ऑप्शन है, जो पहला बी आएगा मैं उस पर यहां मूव कर गया और उसके बाद अगर बीज हैं तो आई विल बी रिजेक्टिंग दैट स्ट्रिंग व्हिच शुड बी एक्सेप्टेड। तो NFA करेक्ट NFA कौन सा होगा, व्हिच एक्सेप्ट द स्ट्रिंग्स व्हिच आर देयर इन द लैंग्वेज एंड रिजेक्ट्स ऑल द स्ट्रिंग्स व्हिच आर नॉट देयर इन द लैंग्वेज। वहां पे गड़बड़ हो जाएगी। तो इट इज रिजेक्टिंग अ स्ट्रिंग व्हिच इज देयर इन द लैंग्वेज। ठीक बात है, ठीक है। तो इसमें अगर आपने, जैसे मैंने आपको स्ट्रिंग दे दिया BA लेट्स से द स्ट्रिंग इज बी ए, आप पहले बी पे कहां चले गए, यहां आ गए, फिर ए आया, फिर बी आएगा, मैं क्या करूं, जबकि ये स्ट्रिंग लैंग्वेज से बिलोंग करेगी, राइट? तो इस तरह से हमने कंटेनिंग ए डिस्कस किया था, कंटेनिंग बी भी सिमिलर लाइंस पे डिस्कस किया जा सकता है, राइट? क्लास में एज फार एज आई रिमेंबर वी डिस्कस कंटेनिंग ए, ठीक है? नाउ अब दिस इज कंटेनिंग ए बी, इस केस में हम यहां से ए को रिमूव नहीं कर सकते और ना ही यहां से कर सकते हैं। क्यों नहीं कर सकते हैं? लेट अस से माय स्ट्रिंग, इफ आई रिमूव दिस ए, लेट अस से माय स्ट्रिंग इज ए बी, आप पहले ए पे यहां आ गए और दूसरे ए पे कोई ट्रांजिशन ही नहीं है, यू विल बी रिजेक्टिंग दिस स्ट्रिंग, जबकि ये स्ट्रिंग लैंग्वेज से बिलोंग करती है। तो ये आप ऐसा नहीं कर सकते हैं, इस ए को आप यहां से नहीं हटा सकते। सिमिलरली आप इस ए को भी यहां से नहीं हटा सकते। क्यों नहीं हटा सकते? लेट्स सी, इफ आई गिव द स्ट्रिंग, इफ माई स्ट्रिंग इज ए बी ए, अगर आपने पहले ए बी पे यहां आ गए और उसके बाद अगर एज आ रहे हैं तब प्रॉब्लम हो जाएगी। आप ए बी पे Q2 पे गए और उसके बाद आपने यहां पे ए हटा रखा है, तो यू विल बी रिजेक्टिंग दिस स्ट्रिंग, बट दिस स्ट्रिंग बिलोंग्स टू द लैंग्वेज बिकॉज द स्ट्रिंग कंटेन्स एन ए। तो हमेशा एक बात याद रखनी है, स्ट्रिंग्स विच आर देयर इन द लैंग्वेज शुड बी एक्सेप्टेड एंड स्ट्रिंग्स विच आर नॉट देयर इन द लैंग्वेज शुड बी रिजेक्टेड। ये आपने यहां पे याद रखना है, राइट? ये अगर एक स्टेप अगर आप याद रखेंगे, एक पॉइंट याद रखेंगे विच इज वेरी वेरी इंपॉर्टेंट पॉइंट, स्ट्रिंग्स विच आर देयर इन द लैंग्वेज शुड बी एक्सेप्टेड एंड स्ट्रिंग्स विच आर नॉट देयर इन द लैंग्वेज शुड बी रिजेक्टेड, देन यू विल नेवर मेक अ क्वेश्चन रॉन्ग। ऑलराइट, so that's all about this session, guys. So this was a practice session. If we check our schedule, we have already discussed introduction, we have already discussed DFAs, we have already discussed minimization of DFAs, we have discussed NFAs, we have already discussed NFA to DFA conversion and epsilon NFA, and now this session was a practice session, right? So in the next session we are going to cover our syllabus further, we are going to cover regular expressions and we'll see how to write regular expressions for regular languages. What are regular languages? We'll see that in the next session. I'll see you guys. Thank you.